This video, we're going to talk about the metric system. So the basic premise of the metric system is that all of its subunits are base 10. And what do I mean by that? Okay, well, when we talk about 1 foot has 12 inches. When we look on our ruler, the ruler usually has measurements in sixteenths. So you would have 1/16 of an inch, you would have 1/8 of an inch, then you would have 1/4 of an inch, then you would have 1/2 of an inch, and so on. But in the metric system, we actually don't have anything but 10. So if you're looking at your meter stick, there are 10 millimeters in 1 centimeter, and then 10 centimeters in 1 meter, and 10 meters in 1 decimeter. We are essentially, every smaller unit has a factor of 10 in the metric system. When we're talking about all these different units, we have what we call prefixes. So there's the prefix tera, that has the abbreviation of T, and that's 10 to the 12th. So a terabyte is 10 to the 12th, or 1 quadrillion bytes. So if you hear about a terabyte computer, that's what it is. And we can write 10 to the 12th. If we were writing it in scientific notation, we would be writing it like that. So these two notations are equivalent. The next one after tera would be a giga, and that has the abbreviation of G, and that's 10 to the 9th, or 1 times 10 to the 9th, or 1 billion times of something. There are ones between giga and tera, but they're not commonly used, so I wouldn't worry about knowing them at this time, but they do exist. Okay, it's just very few people have them memorized, because after we get to big enough numbers, we start looking at differences of factors of 1,000 or 3 zeros rather than a factor of 10, because it's just more efficient that way. Less than giga would then be mega, which is a capital M, and that's 10 to the 6th, or 1,000,000 times. Next, we have kilo. Kilo is 1,000 times, and that has the abbreviation of K. So that's 10 to the 3rd. When we get smaller than kilo, we start using smaller ones like hecto, which is a lowercase h. It's 10 to the 2nd. Deca, which is a capital D, which is 10 to the 1. When we have 10 to the 0, 10 to the 0 is just no prefix. So that would be a meter, or if we were looking at length, or it would be a liter if we were looking at volume. So it's just no prefix, and that would be 10 to the 0, or if we're going to write that in non-scientific notation, just 1, because any number to the 0 power is a 1. Now we're going to go to measurements that are less than 1 of a unit, so less than a meter, or less than a liter, or less than a second. The first one of those that we're going to look at is deci, which is a lowercase d, and that's 10 to the -1, or 1 times 10 to the -1, or 0.1, if you want to look at it that way. After deci is centi, and that's a very commonly used one in length. We talk about the centimeter all the time, and that's 10 to the -2, 1 times 10 to the -2, or 0.01. Then we have milli, which is another really often used one, and that has the abbreviation of an M. It's 10 to the -3, or 1,000th. Next, we have micro, which is represented by a Greek mu symbol, and that's 10 to the minus 6th, or you could write it 1 times 10 to the minus 6th, or 0.12345 and a 1. So 5 zeros and a 1 would be 1 times 10 to the minus 6th. Followed by nano, which has the abbreviation of N. That's 10 to the minus 9th, or 1 times 10 to the minus 9th. And I'm not going to write the numbers all the way out anymore because I'm running out of space on my slide, but it would have 8 zeros and then a 1 after the decimal point. Finally, we have Pico, which has a abbreviation of a P, and that's 10 to the negative 12th, 1 times 10 to the negative 12th, or a 0 with a decimal point with 11 zeros and then a 1. And femto, which has the abbreviation of F, and that's 10 to the minus 15th, or 1 times 10 to the minus 15th. Or you could write a 0 with 14 zeros after the decimal point and a 1. So here are all of the prefixes and what they mean that you'll need to know for the nursing exam. Okay, so here's our table of metric units written a little bit neater, and we can use this to look at our conversions. So I suggest that you make a mnemonic to learn what the order of these are. Then we can use this to do our conversions. Let's say that we want to convert 15 kilometers to meters. So we're going to write our number 15 down. We're going to look here on our little table, and a kilometer is 3 times more than no prefix. So this would be where our meter would be. So that means that since this is more, or it's a larger thing, a kilometer is bigger than a meter, that means that our decimal point is going to have to move to the right, and it's going to have to move to the right 3 times. 1 to go from here to here, 1 to go from here to here, and 1 to go from here to here. So that means it's going to be 1, 2, 3. It's 15,000 meters is going to be our answer then. So if we try a second question, let's say convert 15 millimeters to kilometers, then we would come over to our little table, and we're going to look at our millimeter, and it's 1, 2, 3 less than orders of magnitude less than 1. So a kilometer is a much bigger thing than a millimeter, and that means that our number is going to have to get smaller because there are fewer big things in small things than there are small things in big things. That means that we'll write our 15, but we're going to go, instead of going to the right this time, because we're going to a larger unit, that means that the number has to get smaller. And there's a difference of 1, 2, 3, 4, 5, 6 places. So where our decimal place originally started here, we're now going to have to move it 6 places, and we're going to move it 6 places to the left so we can get a smaller number. So the answer then is kilometers. That's the super easy way to do it. Now, there's a mnemonic that I often teach my students in my chemistry classes for remembering it, but it only works for kilo through nano. And it is that King Henry danced, and some textbooks will also write that as shorthand for Deca as a DA rather than a capital D versus a lowercase d. So this has to be a DA word. Danced, drinking, chocolate, milk, many, that's a mu right there. So if we can remember that the second one is the mu symbol, nights. And then if you can remember that these are 10.3, 10.2, 10.1, and then in between danced and drinking is just the plain old 1. And this is 0.1, 0.01, 0.001, and now we start going down. We're adding 3 zeros. 0.1, 2, 3, 4, 5, 6, or 4, 5, 1, and so on. And that will maybe give you a mnemonic that you can use to remember this setup. And you might have to remember the Tera, Giga, and Mega, and the Pico and Femto. But I suspect those won't be used terribly much, because generally they're not something that's even used in concentrations of drugs in the body very often. Most of those are done in micro, milli, centi. We don't have a lot of Tera, Giga, and Mega, and Pico and Femto. Picometer and femtometers, those are on atomic scales. So a nucleus is on a femtometer scale in size, and an atom would be on a picometer scale in size. And nanometers would be on the scale of the wavelength of light. So most visible light its wavelengths is on the scale of nanometers. In general, I suspect that most of the questions that you'll be asked will be in this region that my King Henry mnemonic will work with. So previously we discussed how to do conversions between one metric unit and another metric unit, but there are some very common conversions that you probably need to know as well. Probably the most important ones are that 2.54 centimeters is 1 inch, 2.2 pounds are in 1 kilogram. So let's say that you were asked to convert 10 pounds to kilograms. In order to accomplish this, we're going to use something called dimensional analysis. And dimensional analysis simply describes the process of canceling out units and using the canceling out of units to determine when you multiply and when you divide to do a conversion. To do 10 pounds converted to kilograms, we would first write the information that we were given. So we were given that we have 10 pounds, and then we're going to use our conversion factor that we have. The 2.2 pounds equals 1 kilogram. And so since we're trying to get into kilograms, our kilogram number is going to go on top. And since the units that we started with are pounds, and we need to get rid of those units, then we would take the pound conversion number, or this side of the equation, and we would put that on the bottom. And then we can cancel out, just like if you have 3 over 3, they cancel each other out to 1. If you have pounds over pounds, they cancel each other out to no units. And so then we're going to take and multiply our 10 times 1 and divide it by 2.2. So that would give me 4.5 kilograms. So basically, 10 pounds is 4.5 kilograms. So if we wanted to do a inch to centimeter problem, so let's say that we have 24 inches and we want to convert those to centimeters. Again, we would write down the beginning information that we started with, and we're going to put our fraction in for our conversion factor. The 1 inch is going to have to go on the bottom so that we can cancel out the inch units. So we'd write that here. And the 2.54 centimeters are going to go on the top because we are trying to find the number of centimeters we have. And so we're trying to get into the units of centimeters. So the inches will cancel out, not the 24. I'm not sure why that did that. And so then what we'll do is in the calculator, we'll multiply 24 times 2.54 divided by 1. And that will give me the answer of 60.96 centimeters. So that's how you do basic dimensional analysis. Not only will we use that to do non-metric conversions, you can use them to do metric conversions as well, although the other way is a little bit faster, but you will also use them for stoichiometry when we get to that section. So this concept of canceling out units is really a critical one to understand. There's also a relationship between distance and volume. For instance, let's assume that we have a cube. This cube is 1 centimeter long, 1 centimeter wide, and 1 centimeter tall. If we went back to our early math classes, we would learn that the volume of that cube is the length times the width times the height. And so in the case of this cube, we would have a volume that was 1 centimeter times 1 centimeter times 1 centimeter, which would be 1 centimeter cubed. Because just like when we're dividing, and if we were to divide inches by inches and we get 1, when we multiply centimeters times centimeters times centimeters, we get centimeters cubed. Just like if you multiply 2 times 2 times 2, you get 2 cubed, which is 8. So 1 centimeter cubed has another very important name that's used in the medical community, and that's cc. So 1 centimeter cubed is exactly the same as 1 cc. And it's also the same by definition as 1 milliliter. So there is a connection between this distance value here of a centimeter and the metric unit for volume, which is a milliliter, which is usually how it's discussed in chemistry and science classes that are physical science classes. But then more biological science classes will use the term cc, but they're all related. 1 cc is a shorthand for saying cubic centimeter. If you look at the words, right, it's cubic and centimeter, and so that's where your cc comes from. And 1 centimeter cubed is the same thing as a milliliter. So it's very important that you keep all of these things in mind, because there is a relationship between volume and distance, and that is something that might come up. Read the following questions, then pause your video and answer them. So if a child weighs 75 pounds, that is the first bit of information that I'm going to write down when I'm doing my conversion. Now you'll remember that there's 2.2 pounds in 1 kilogram. So therefore, I would put the 1 kilogram on the top, since I am attempting to solve for kilograms, and then my 2.2 pounds will go on the bottom. And my pound units will cancel out. That will leave me with the units of kilograms. So then in my calculator, I will multiply 75 times 1 and then divide that by 2.2. That gives me an answer of 34 kilograms. For the second one, I need to remember my metric conversion chart. So I'll need to do a King Henry danced drinking chocolate milk many nights, and this is 10 to the third, 10 to the second, 10 to the 1, 10 to the minus 1, and remember, in between here is just the plain 1, or the unit with no prefix, 10 to the minus 2, 10 to the minus 3, 10 to the minus 6th, and 10 to the minus 9. And it's important to note that when we get down here, we're going down by a factor of 3, not by a factor of 1 anymore. We're then starting with 1.5 liters. I'm going to write my 1.5 value down. That is, the liter would be right here because it doesn't have any prefix in front of it. What I'm going to do is Now I'm going from liters to milliliters. That's a factor of 1, 2, 3. And a milliliter is smaller than a liter because it's below on this little scale. So that means that I'm going to go to the right, because since a milliliter is smaller than a liter, that means that my ending number is going to be bigger because there's more milliliters than there are liters, because a liter is a bigger thing and a milliliter is a smaller thing. So that means I'm going to move to the right 1, 2, 3 spaces, and I'm going to put my zeros here and my new decimal point there. So my answer would be 1,500 milliliters. Make absolutely sure that you're very confident in what direction you're going. If you're going from higher to lower, that means that your number has to get bigger. It's the reverse. If you're going from the bottom up, then that means that your number is going to have to get smaller because your units are getting larger.